Hello students, welcome back. Let's go to problem 2. I already explained problem 2 in two different methods. First, using critical value method. Second, using probability value method. In this video, we're going to do the same thing using the hybrid method or the classical method. This is the hardest method, as a matter of fact, theoretically speaking, but our textbook author talks about it to a certain degree, so let's do it. Every semester, I do have some students who take this method and do it successfully. And of course, there are many more students who take this method and not successfully. So usually, I advise students to do this. And for that, you can go to the first video. Okay, here we go. Let's start from the very beginning. The article, A Trial of Lopinavir-Ritonavir in Adults Hospitalized in Severe COVID-19, New England Journal of Medicine, Volume 382, 19, page 1787 to 1799, May 7, 2020, by B. Cow et al., reports the following study on possible SARS-CoV-2 virus treatment with Lopinavir-Ritonavir, originally a HIV medicine. A total of 199 patients with laboratory-confirmed SARS-CoV-2 infection underwent randomization. 99 were assigned to the treatment group and 100 to the standard care group. The article summarizes the main result as follows. Mortality at 28 days was similar in the treatment group and the control group, 19.2% versus 25.0%. Okay, all right, that's the setting. And let's begin. First, let us set up the hypotheses. We are doing two-sample inference. Hypothesis, set up hypotheses, okay. We are doing two-sample inference, and the default is no difference. Unless a problem explicitly says the difference is 17, or difference is believed to be 21, unless a problem explicitly says so, the default is no difference. So no difference, difference is 0. Now the second part, difference is less than 0 or greater than 0. True criteria. Number 1, you have to read through. And alternative hypothesis here means the medicine works. So does it mean smaller mortality rate or bigger mortality rate? Think. You want smaller mortality rate, so difference should be less. So less than 0. That's one way. Another criterion, look at the sample study result. I got negative 5.8%. Negative. So it's got to be negative. If you use plain equality and plain less than symbol, that's fine. I'm not going to take off any point. But to be a little bit more perfect, I used statistically similar, no difference. Statistically significantly difference, two different symbols here. That's because I'm a teacher. If you just use typical math symbols, that's fine. Nobody will take off any points from there. Alright, these are the hypotheses, and let's go to the solution. And the starting point is always the picture. In this case, you have to do the standard error, but you already did it in problem 1a. So I'll just skip over. This is SC1 squared plus SC2 squared. And turns out this plus that and all the square root. Next, picture. And please remember this process, outline, center, end, and shade. Outline, it doesn't have to be real pretty. Center is always 0. End, you want the critical z value, z alpha value. But here, I just use z1 and z2, left hand side. Sometimes I may use z star or something else. And then shading. Here I'm shading with two different colors. That's the best, but if you have just one color, let's shade only this outside part, left hand side part. The middle part, that's a big chunk, so you don't want to shade that, white part. And this one dark. Okay, the shading is done. And then let's go to computation. And computation here is theoretical a little bit different because you see this picture is standard normal picture. So you're not really looking for 5.8% or this percentage points, but everything here should be rescaled into z values. And conceptually, that's a little bit difficult to handle. So you have to convert all those inches into the centimeters first, and then do some work in centimeters. Okay, shall we begin? Well, all right. Let's find the z-score for this guy, -5.8. So we want z-score of n minus center over SC, which you calculated in problem 1a. And that's going to give you something. Now, how do you compare? Well, alpha value is 5%, and you have to compare this with z-score associated with this 5%. What is it? Z-score associated to this 5%. This should be 5%. Where's that z-score? 5%, right here, -1.64, that's when you have 0.0505, and -1.65, you get 0.0494. So somewhere in between. So let me estimate it as -1.645. So Z alpha is approximately -1.645. So you're comparing these two. And then how do you compare and how do you get conclusion? Another tricky part, but if you compare correctly, let's see. This value is bigger than this, means a little bit to the right, so it falls into the null region. This value being smaller than that, left, falls over there, that's in alternative regions, alternative wins. What happens here is -1.65 versus -0.99 approximately, so it falls into the null region. So it goes like this. Conceptually, it's hard because you have to convert both of them into z. Both of them. Still, for two-sample inference, it's not that bad. By the way, if you go over to this critical value method, you just look for the critical value directly, and you just compare that with -5.8. You don't really have to convert both and then understand both. You just convert once, and then you don't really have to understand the total detail. You just see whether this value, given difference, is close to null or too far away to null. So you don't really have to think too much about it. So this method is similar to hybrid method, but easier to apply. I don't understand why our textbook author is talking about the probability value method and hybrid method and not this one. I don't know. I don't really understand it. Okay, all right. So much for hybrid method, and let's take a little bit of time to do confidence interval method. Okay, all right. Confidence interval method does not apply to proportion. Oh, that's right. For means, you can calculate a confidence interval, one-sided confidence interval, and get a confidence bound, and then compare that. You can do that, but for means, it doesn't apply. Okay, that concludes all methods, and that concludes problems 1 and 2.